Pre-Calc. Today you're going to be learning how to divide radical expressions. If possible, I want you to divide the radicand on top by the radicand on the bottom and then simplify. So when you see something to this nature, you've got like the nth root of a term, I'll just call it A, divided by the nth root of B. You can, if you need to, write this as one big fraction. It also works the opposite way. So, for example, if you see the square root of 25 over 36, you can break that up into the square root of 25. Instead of like thinking of it like a fraction, you can do the square root of the top number divided by the square root of the bottom number, and it will work nicely even without a calculator. And so this one is going to be 5 over 6, 5/6. So again, this rule can go forward or it can go backward. You're going to divide a radical expression by rationalizing the denominator. We used that word when we did the complex unit last unit. You're going to rewrite the problem so there is no radical in the denominator. So your whole goal is to make sure you do not leave a radical, square root, cube root, fourth root, whatever it is, do not leave it in the denominator of your answer. Okay, example 1. We're going to divide the following. You see 1 divided by radical 2. I want you to notice that the top is not a radical, so we cannot do what I just said on the last slide. You're going to have to rationalize, which means you're going to have to multiply the top and the bottom by the square root of 2. Okay, so in the numerator, again, this is not a radicand, so you'll just multiply 1 by the 1 in front. That's going to be 1 radical 2. The denominator is going to be 1 times 1, which is 1, square root of 2 times the square root of 2, which is the square root of 4. Okay, then you're going to be left with the square root of 2 divided by this square root actually simplifies to a nice whole number, and this is the final simplified answer. And again, just a quick reminder, the things that you want to look for to make sure your answer is simplified: you do not want a negative number in the bottom of your answer. There cannot be a radical down here. No fractions, no decimals. So basically just make sure that you've simplified and try to avoid those things. Example 2, we've got the cube root of 15x to the second divided by the cube root of 5x. Notice that both of these are the same index number and they're both radicands. So one thing you can do is write this one as one big fraction, especially if you know the numerator is divisible by the denominator. So we're going to say 15x to the second divided by 5x. Okay, we're going to drop the cube root down, cube root symbol. 15 divided by 5 is 3, and x squared divided by x to the first is x to the first. And then notice that this one doesn't even have a division bar. You actually cannot simplify the cube root of 3 or the cube root of x. No other way to write it, so that is the best answer. Okay, example 3. You have the square root of 21x to the 10th y to the 4th divided by the square root of 7xy to the second. Again, you're going to pay attention to the radicands. If you know that the top is divisible by the bottom, then my advice is to write it as one big fraction. So we're going to put these together. Then you're going to simplify, keep the radical. You're going to simplify this division problem. 21 divided by 7 is just 3. X to the 10th divided by x to the first is x to the 9th. Y to the 4th divided by y to the second is y to the second. Okay, last, you're going to see if you can simplify any of these pieces. You cannot take the square root of 3. You actually can simplify the y to the second, and then y to the ninth can be, or x to the ninth can be written as factors. So next step, I would change x to the ninth over to x to the eighth. So anything you've learned in the past, you need to use it. X to the eighth times x to the first, and then bring down your y squared. And then remember from the past, I always underline the pieces I can actually simplify. So this final answer should be like square root of x to the eighth, which is x to the fourth, the square root of y to the second, which is y to the first, and then you're going to be left with the square root of 3x. And that is it for that one. Okay, number 4. I'll notice on this one I have a 3 with no radical on top, 3 divided by 2 radical 3. Also notice that this is a single term, it's one term. I cannot leave the radical on the bottom, so I'm going to have to rationalize. To rationalize this, you're going to have to multiply the top and bottom by radical 3. Again, the reason that's going to work is kind of thinking ahead, that's going to give me a square root of 9, and I can actually simplify the square root of 9. Okay, back to the top. Notice that again that this is not a radicand, so you're going to multiply 3 times 1, and you're going to get 3. And then you're going to drop your radical 3 down. On the bottom, it's 2 times 1, which is 2. Radical 3 times itself is radical 9. Okay, next step. Square root of 3 cannot be simplified, so I can't do anything there. Recopy. Denominator, I'm going to drop my 2 down and then evaluate the square root of 9, which is just 3. So now I'm left with numerator stays the same. Denominator, 2 times 3 is 6. And then you always want to see if anything can simplify. Please notice again that the denominator does not have a negative, so that is good. I do not see an imaginary number. I don't have a radical. I don't see a messy fraction or decimal, so all of those things are good things. But I do want you to notice that the numbers here, 3/6, is a fraction, and we know to reduce fractions when we can, so 3/6 becomes 1/2, and then I'm just going to leave the radical 3 on top where it is. So actually this would be the best answer that would get me full credit. Number 5, cube root of x divided by the cube root of 2. Okay, again, notice that there is a single term here. Also, even though these are both underneath the radical, dividing x by 2 won't simplify, so I can't write it as one big fraction like I did on this one, on number 3. So I'm back to the rationalizing process. I got to do the cube root of something. I want to caution you against this because this is a common mistake. When you're dealing with square roots, you always can use the same value and it will work. It will not work here. I'm going to go ahead and write it down, but this is incorrect. I want you to kind of look ahead. The cube root of 2 times the cube root of 2 would actually give you the cube root of 2 times 2 is 4. Well, perfect cubes are 1, 2 to the third is 8, 3 to the third is 27, 4 to the third is 64, 5 to the third is 125, and so on and so on. Well, 4 obviously is not in that list, so me rationalizing by putting the same radical to the side is not helpful every single time. So I did want to caution you against that because that is a common mistake. So I cannot use the cube root of 2 to rationalize. So what I have to do is kind of think backwards. I got to multiply the top and bottom of this problem by the cube root of something. What I suggest you do is, if it's a cube root, you make yourself a list of perfect cubes to the side, like I did. And then you ask yourself, what can I put here so that when I multiply it by 2, it's going to equal one of these numbers? I'm going to say that again. What can I put here so that I multiply it by 2, it's going to equal one of these numbers? Well, since 2 will divide into 8 4 times, then that means I could actually use a 4 on top and bottom. As long as this is the same as this, that's a big 1, that's a different way to write 1, then you're not changing the problem. Alright, numerator, I'm going to multiply straight across. I'm going to get the cube root of x times 4, which is just the cube root of 4x. Denominator, I'm going to get the cube root of 2 times 4, which is 8. Well, cube root of 8 actually is going to simplify for me, which is nice. So, and the numerator, I'm going to leave it alone. And the denominator is going to become a big 2. And so again, simplify when you can. I don't see how I can simplify the cube root of 4 or x. Dividing by 2 is acceptable, and so that is the final answer. Okay, we'll try another one. Number 6, the square root of 75x to the 5th divided by the square root of 12xy squared. Couple things again, just repeating things you've got to pay attention to. They're both radicands. Writing it as one big fraction, I don't think it's going to be that helpful because 75 is not divisible by 12. It is one single term on the bottom. It is a nice square root. So me multiplying the top and bottom by the same factor, like 12xy squared, should work. Sorry, that is sloppy. There we go. So let's try that. We're going to do 75 times 12, and that is 900. Let me make sure I bring down my radical. X to the 5th times x to the 1st is x to the 6th. And I'm going to have to drop down my y squared. Okay, let's go to the denominator. I've got 12 times 12, which is 144. I have x times x, which is x to the 2nd. And I have y squared times y squared, which is y to the 4th. And you're going to notice that the denominator is going to work out very nicely. The numerator, the square root of 900 is going to simplify. The square root of x to the 6th is going to simplify, as well as y to the 2nd. So actually, right now, it's looking like everything's going to simplify nicely for me. We're going to go ahead and type this in our calculator if we need to. Square root of 900. And you should have gotten a 30 for that. The square root of x to the 6th is x to the 6th divided by 2, which is 3. The square root of y to the 2nd is y. Denominator, square root of 144 is just 12. The square root of x to the 2nd is x. And the square root of y to the 4th is y to the 2nd. Alright. The very next thing I'd like you to do, again, pay attention to the denominator. I like how it looks. I don't see a negative or a fraction or a decimal or imaginary number or a radical. But I do notice that the top and the bottom have the same variables, and so just from Algebra 1 you learned how to do like a quotient rule where you divide the coefficients. So like 30 divided by 12. We're going to use your calculator and then give me the fraction answer. Okay, so that should be 2.5 on a calculator. The fraction answer for that would be 5/2. X to the 3rd divided by x is x to the 2nd. And then y divided by y to the 2nd, remember you're subtracting powers. So 1 minus 2 is actually a -1. And you also, brings up another point, you learned in algebra you can't leave negative powers. And so it's best to change the position of it. So we're going to copy down our fraction. We're going to leave x squared where it is. And then that y to the negative first is going to be relocated to the denominator of your answer, and it's just going to become y to the first. When you relocate negative exponents, it changes to a positive. And again, that's a rule from Algebra 1 and 2. Alright, we're going to try one more. On number 7, I want you to notice in this problem that I have actually two terms in the denominator. We learned when we had a binomial in the imaginary unit that we were supposed to use what's called the conjugate, and that means change the sign in the middle. So I'm going to come over to this problem to rationalize. I'm going to multiply the top and bottom by the conjugate of 2 plus radical 3, which would be 2 minus radical 3. I would make sure that I use parentheses around all of this, so that way you would know when to use FOIL, when to just distribute, and so forth. Okay, your eyes focus on the top. I have one term here and two terms here. So a monomial times a binomial means I'm just going to have to distribute. 12 radical 6 times 2. Notice this 2 is not underneath the radical, so you multiply 2 times 12 and you bring down 24. And then it does have a radical with it, so 24 radical 6. Then you're going to take this term and multiply it by the last term. 12 radical 6 times negative 1 radical 3. 12 times negative 1 is negative 12. Radical 6 times radical 3 is radical 18. Denominator, you see two terms here, two terms here. You're going to use FOIL. First, 2 times 2, bring down your answer. Outside, 2 times a negative square root of 3. It's the 2 times negative 1, which is negative 2, and drop your radical down. Inside, square root of 3 times 2, they're both positive, so I'm going to get a positive back, 2 radical 3. And then last, this term times this term, positive times negative is negative. You can do 1 times 1 if you want to. Square root of 3 times the square root of 3 is the square root of 9. Now it's time to see if we can simplify. First term has a 6. Square root of 6 is not divisible by any perfect square, so the first term is going to stay as it is. 18. 18 can be written as 9 times 2. So we're going to write it like this. We'll come back and simplify that in a minute. Look at the denominator now. These terms are like radicals. They have the same radicand. You're going to go ahead and do what this coefficients tell you. Negative 2 plus 2, that gives you 0. So they're gone. You're going to drop your 4 down. You're going to drop your minus sign down. And the square root of 9 turns out to be a nice whole number of 3. Okay, next step. We're going to recopy the 24 radical 6. Bring down your minus 12. Square root of 9 is just 3. And then drop your radical 2 down. And the denominator is just going to be, excuse me, just going to be 1, so I'm not going to write it. So I'm just going to circle this. Oh. Forgot something. I sure did. I didn't multiply, did I? So let me do this. I'm going to drop this down, and then I'm going to say 12 times 3 is 36. And then drop my 2. So this is my final answer. Okay. Alright, so that's how you divide radicals, all kinds of different types. Just make sure that you understand those types, and then we'll try that in the practice.